Deep within South Africa's Rising Star cave system, explorers discovered an anomaly completely isolated from the surface world. Etched into the gray dolomite pillars of the Naledi subsystem are deliberate geometric crosshatchings. The report proposes a specific attribution. These markings were made by Homo naledi, an extinct hominin, between 241,000 and 335,000 years ago. Homo naledi possessed a brain roughly one-third the size of our own, alongside a mosaic of primitive and derived physical traits. For decades, the scientific consensus has held that durable, abstract meaning-making requires the large cranial capacity of later hominins, like Homo sapiens. Because of this strict biological contrast, the scientific community is highly skeptical. Peer reviewers evaluating this exact claim officially classified the supporting evidence as incomplete. To evaluate if this claim can survive rigorous scientific scrutiny, we have to strip away the sensationalism. We need to deconstruct the physical, taphonomic, and spatial evidence and look strictly at the raw data. When evaluating anomalous rock markings, the first hypothesis to test is always natural geological weathering. The cave walls here are composed of Malmani subgroup dolomitic limestone. This specific rock matrix is packed with dense layers of ancient fossil stromatolites. Over millennia, chemical weathering slowly dissolves this limestone, eating away at the rock to form deep, erratic natural fissures called elephant skin patterns. In cross-section, natural weathering creates deep, jagged crevices. The Naledi markings, by contrast, are remarkably shallow, uniformly wide grooves. Natural fissures organically follow pre-existing structural weaknesses. The Naledi lines actively ignore these fault lines, crossing directly over natural fracture directions. This is clear when observing the lines interacting with embedded fossil stromatolites. A straight groove maintains its linear integrity, passing directly over irregular topographical bands. Dragging a tool perfectly straight over this uneven surface requires significant physical force and intentional control. Passive chemical erosion cannot maintain strict linear integrity across an irregular, varying substrate. The physical data eliminates natural weathering as a viable taphonomic model. With geology ruled out, we have to examine the micromechanics of the lines themselves to test for deliberate tool use. Dolomite is exceptionally hard. Creating a visible mark in this specific material cannot be accomplished with a single, casual strike of another stone. Under magnification, the microscopic structure reveals multiple parallel, overlapping incisions. It took sustained passes with a sharp implement to carve a single groove. Because of this, intersecting grooves create a clear temporal stratigraphy, letting us order the physical actions. On panel A, we can trace a chronometric sequence where a newly cut horizontal line cleanly overcuts an older vertical line. This demonstrates a multi-stage interaction with the rock surface over time. Researchers also identified external sediment and grit packed deeply within the base of some of these engraved grooves. This applied foreign grit indicates the surface was treated post-etching, likely to abrade, polish, or create visual contrast against the gray dolomite. Precisely ordered striations filled with contrasting grit point to a sustained intentional manufacturing process, which is wholly incompatible with random environmental damage. The second major alternative hypothesis is animal bioturbation, the possibility that cave bears, leopards, or porcupines seeking shelter scratch the walls. Animals frequently leave deep claw scores in softer limestone caves, so we must evaluate the specific material science of the Naledi subsystem. This chart visualizes the Mohs hardness scale, plotting animal keratin claws, measuring 2.0 to 2.5, directly against the Malmani dolomite cave walls, ranking 3.5 to 4.5. It is materially impossible for softer keratin to deeply incise this harder mineral substrate. This material constraint aligns perfectly with the fossil record of the cave. There are no carnivore remains, no fossilized coprolites, or tooth marks in the subsystem. By coupling quantitative Mohs hardness data with a complete lack of biological traces, we can conclusively eliminate animal scratching as the source of rock scoring. This leaves the final alternative hypothesis. Modern human cave explorers, or late Pleistocene Homo sapiens, made the marks. To test this, we must look at the spatial isolation of the cave. The rising star system requires navigating extremely narrow access points from the surface. Reaching these specific panels requires a treacherous 120-meter route, descending 30 meters vertically through a labyrinth into the pitch-black Naledi chamber. Panel A is located in an isolated position on a rock pillar, right at the narrow choke point connecting two deep chambers. Only 52 documented modern humans have navigated this specific route, and there is zero evidence of modern metallic tool marks left on the cave walls. What we do find, just a few meters away from the engraved panels, are the dense, fossilized remains of Homo naledi. Researchers applied rigorous geochronological dating methods, specifically electron spin resonance and uranium-thorium dating, to both the hominin teeth and the flow stones surrounding the fossils. These isotopic tests establish a conservative chronological window for hominin activity in this specific chamber, strictly between 241,000 and 335,000 years ago. With modern humans excluded by spatial isolation and lacking metallic traces, physical evidence leaves Homo naledi as the only verified candidate in the subsystem. We now have to step back and view these markings against the broader timeline of evolutionary meaning-making and geometric paleoart. The crosshatchings found in the Naledi subsystem are almost identical to the geometric patterns created thousands of years later by Homo sapiens in Blombos Cave. They also share striking similarities to well-documented engravings left by Neanderthals in Gorham's Cave in Gibraltar. If these markings are definitively verified, they completely decouple complex symbolic behavior from a large cranial capacity. Yet the scientific community remains cautious. The eLife peer review assessment delivered a very specific verdict on the discovery. Significance, important. Evidence, incomplete. The evidence remains officially incomplete because the current data relies entirely on observational photography. The researchers have not yet conducted the invasive physical sampling required to confirm their hypothesis. Verifying this claim requires rigorous next steps, including residue sampling of the grit inside the grooves and controlled experiments replicating etching on native dolomite. The physical taphonomy strongly points toward intentional hominin design, but validating a discovery of this scale requires holding the data to the absolute highest standard of empirical proof. 30 meters below the surface of South Africa, the Rising Star cave system forces explorers through narrow, pitch-black chutes of jagged limestone. Navigating this deep into the Naledi subsystem reveals the exclusive domain of Homo naledi. Their fossilized remains are scattered throughout these isolated chambers. Right at the entrance to the burial chamber, on a natural dolomite pillar, there is a physical anomaly. The rock face is scored with deeply impressed lines, distinct crosshatchings, and overlapping geometric shapes. Finding abstract geometric engravings in this specific, remote location challenges the established timeline of human evolution. Uranium-thorium and electron spin resonance dating place these markings in a strict window between 241,000 and 335,000 years ago. Paleoanthropology operates on a long-standing model. Abstract meaning-making and rock engraving are traits exclusively assigned to the large-brained hominins of the late Pleistocene. Homo naledi possesses a brain roughly one-third the size of a modern human. To prove a species with a brain this small authored these engravings, we have to systematically eliminate every natural and zoological alternative through forensic deduction. Claims that alter our understanding of evolution require airtight physical evidence. The cave system itself becomes a test of the scientific method of exclusion. The first null hypothesis is that these marks are the result of natural geological weathering. The surrounding Malmani dolomite degrades through a process called elephant skin weathering. This chemical breakdown creates deep, expanding fissures that explicitly follow the pre-existing fracture planes of the rock. The engravings on the cave pillar ignore these fracture lines entirely. They are wide but distinctively shallow, directly contradicting the deep weathering patterns found mere centimeters away. The second null hypothesis is biological. Animals, like tunneling carnivores or climbing porcupines, scratched the walls. This chart shows the Mohs hardness scale. An animal claw measures between 2.0 and 2.5. Malmani dolomite is much harder, sitting between 3.5 and 4.5. Biology is physically too soft to score this rock. Furthermore, explorers have recovered zero zoological evidence here. There are no carnivore bones, there are no coprolites, and no burrowing traces anywhere in the subsystem. Natural chemistry and zoological biology are physically incapable of producing these exact marks. Creating them requires an external agent wielding a tool. Eliminating natural causes shifts the focus to the microscopic evidence of directed kinetic force. High-resolution macrophotography reveals a series of roughly parallel microstriations clustered tightly inside the main grooves of the engravings. These specific microstriations form only when a hard tool is deliberately and repeatedly passed through the same groove. Many of these tracked lines intersect, crossing over each other to form deliberate geometric shapes. Analyzing the overlap points reveals a chronological order of operations. We can see exactly which line was carved first and which was carved second. The author also actively fought the native structure of the rock, dragging a tool straight through the hard, irregular bands of fossilized stromatolites without losing the linear track. This combination of repeated tool application, sequenced overlapping, and structural defiance serves as physical proof of hominin intentionality. If a hominin made these marks, the final step is proving exactly which species held the tool. The engraved pillar is located in extreme spatial isolation, only a few meters from the established Homo naledi burial features. Early modern humans and Neanderthals are entirely absent from the skeletal and archaeological record of this subsystem. The direct dating of the adjacent Homo naledi remains acts as a hard temporal boundary for hominin presence in this specific chamber. Modern humans are geographically excluded, and the physical mechanics confirmed the markings were carved by hand. Spatial and temporal exclusion leaves Homo naledi as the only viable author. We can validate the significance of the Naledi markings by placing them against the accepted canon of Pleistocene rock art. This image shows a 70,000-year-old rock fragment found at Blombos Cave in South Africa, featuring distinct cross-hatched engravings long attributed to early Homo sapiens. Thousands of miles away at Gorham's Cave in Gibraltar, similar geometric hash marks are definitively attributed to Neanderthals. The structural similarity is striking. The geometric forms carved deep inside Rising Star utilize the exact same crosshatch concepts as these later large-brained hominins. The behavior is morphologically identical, yet the Naledi author predates the human and Neanderthal examples by hundreds of thousands of years. The mechanical evidence confirms intentional tool use, and the spatial isolation limits authorship to a small-brained species from the Middle Pleistocene. The cognitive threshold required for abstract, meaning-making behavior appears to be decoupled from sheer brain volume. The physical evidence inside the Rising Star cave system places the origins of complex thought hundreds of thousands of years earlier than the fossil record previously allowed.